We're now going to start working through the Math 136 test number 2 review. So here it is. I will try and work these problems. And I do have the key. Hopefully the key is correct. So I'm not going to teach everything, but I will, of course, highlight what I'm doing and how I'm doing it. At the end of this review is equations that will be made available for the exam. Matter of fact, here's the key. Just going to tear this apart and keep it handy as I work through these, and hopefully I will not make too many mistakes and be able to get the correct answers. So let's start with number 1. Find the distance between these 2 points. Also find the midpoint. With all these kinds of problems, I almost always do a quick sketch. It's just a good way to check and make sure you're in the ballpark with your answers. So for number 1, 2 points are 1, 4, and -1, -5. So 1, 1, 2, 3, 4. So there's 1, 4, -1, 1, 2, 3, 4, 5. All right, so there we go. Distance formula for 2 points. x2 minus x1 squared plus y2 minus y1 squared. Doesn't really matter. I can just call this point 2 and point 1. X of my second point, 1 minus x of my first point, just -1, all that squared. Y of my second point, which is 4 minus y of my first point, which is -5 squared. One minus the -1 is 1 plus 1, which is 2. 2 squared is 4. 4 minus the -5 is 4 plus 5, which is 9 squared, which is 81. Looks like the distance is square root of 85. And that is correct. It also asks for the midpoint. Midpoint formula actually is not given on the exam, but it's pretty easy to remember. It's almost like you add the 2 x's together, divide by 2, add the 2 y's, divide by 2. It's almost like taking the average. So the x's are 1 plus -1 over 2. And you add the y's, 4 plus -5 over 2. 1 plus -1 is 0. So it looks like it's 0. 4 plus -5 is -1. Looks like the midpoint is 0, -1/2. Now my graph isn't perfect, but if I try and connect these lines, 0, -1/2. Yeah, it's in the ballpark. All right, number 2. Prove that 7, 7 is on the perpendicular bisector of the segment between -3, 2 and 5, -4. So once again, I'm going to sketch this out. So 7, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So maybe there. Now, this on the perpendicular bisector, -3, 2. And 5, -4. So it's almost like we combine these two lines. And then we're saying perpendicular bisector means this line crosses this at a right angle, and it does it right in the middle. So actually from this graph, my graph might not be perfect, but with this kind of problem, for this all this to be true, the lengths of from the point now my picture may not look quite right because I drew it by hand. I'll call this distance 1 and distance 2. For this to be on the perpendicular bisector, these distances have to be the same. That's how we prove it. So basically, this is a problem where we've got to calculate two distance formulas. For both of these, I'll call this 0.2, and then these will be 0.1. So x2 minus x1, that's 7 minus a minus 3. So that's 11. Square that plus, 7 minus 3 is 10. Sorry. And then 7 minus 2 is 5. $125, which this actually simplifies. Hopefully you can remember how to simplify. This is 25 times 5. Square root of 25 is 5. So D1 is 5 square root of 5. Now let's calculate D2. Hopefully it's the same. 7 minus 5 is 2, so 2 squared. 7 minus a -4 is like 7 plus 4, which is 11 squared. So 121 plus 4. So obviously, you can see right now, they're going to be the same. So that proves that this point is on the perpendicular bisector. Number 3, show that the following 3 points form a right triangle. Now this is where we're going to use the Pythagorean formula. So once again, let me just make a quick sketch of these points. It may or may not look like a right triangle because my graphing will not be perfect. But we'll just see how it looks. So the 3 points, the first point is -6, 3. And the second point is -1, 5. And the third point is 3, -5. Now, actually, the sketch for this one is pretty important because in a minute, when I try and apply the Pythagorean formula, I really need to know which one I think is the hypotenuse. So if I combine these points, then I'm going to see what may be going on. So from the looks of it, it's pretty obvious that if it's a right triangle, it's going to be like this. So this is the hypotenuse, and these are the legs. So if I call this A and this B and this C, Pythagoras said hypotenuse squared equals the sum of the squares of the legs. So basically, I'm going to have to use a distance formula 3 times to find the length of 3 sides and then plug it in and see if this equation is true. So for A, distance formula, I'll call this point 2 and this point 1. So for the x is -1 minus a minus 6, -1 plus 6 should be 5 squared. And then 5 minus 3, 2 squared. 25 plus 2 is 29. Looks like I'm saying A is square root of 29. Let's go from here to here. So -1 minus 3 is -4 squared. And then 5 minus a minus 5, that's 10. So that's 16 plus 100. Does this reduce? I think 4 goes into it 25, 29 times. I think it's 2 square root of 29. Now let's calculate the length of C. We'll just call this 2 and this 1. So -6 minus 3. So -9 squared. And then 3 minus a minus 5, that's 3 plus 5. It's like 8 squared. It's like 81 plus 64, which is 145. I wouldn't even worry about simplifying it. I didn't really need to simplify this one. Matter of fact, it'd probably be easiest if I left it like this. Because now if I plug those in, so C is square root of 145. So I'm going to square it. Does that equal A squared? Square root of 29 squared plus B squared. So this is 145 equals 29 plus 116. And Pythagorean formula doesn't work, so this is a right triangle. So I had to apply the distance formula 3 times. All right, number 4. Are we done with the distance formula? Oh, I guess not yet. Given the 3 points is ABC and an isosceles triangle. Hence, an isosceles triangle is a triangle where 2 sides are equal. So find the distances of the three sides. Let's see if two of them are equal. That's true, although I'm going to take a shortcut and I'm going to still plot these points, and maybe instead of having to do all three of them, maybe I'll make a guess as to which two are the same length. Maybe save a little bit of time, we'll see. So A is 4, -2. B is 5, 5. And C is -1, 3. Which ones of these might be the same length? Looks like they all might be the same. I'm going to guess, at least to start, because as soon as I find two are the same, then I'm done. I'm going to guess I don't know. Let's just do BC and BA. We'll call this distance 1, distance 2. Actually, I should put the points here, it'd be easier. So this one's 5, 5. C is -1, 3. And A is 4, -2. So let's just call this distance from C to B. Five minus 1 is 6. 6 squared is 36. 5 minus 3 is 2. 2 squared is 4. I'm not even going to simplify it. It's unimportant for this problem. Now let's look between B and A. 5 minus 4 is 1. 1 squared is 1. 5 minus a minus 2 is 5 plus 2 is 7. 7 squared is 49. Well, looks like those aren't the same. So I got to guess I have to do D between C and A. Hopefully it's the same as one of these. -1 minus 4 is -5 squared. 3 minus a -2, 5, which is 5 squared. Okay. So it looks like B and A and C and A are the same. So we confirm it is an isosceles triangle. All right. Couple intercepts problems. Sketch the graph of the equation and give the x and y intercepts. Y equals 2x minus 4. This is number 5. Now I can graph this knowing this is a straight line in our sort of our shortcuts on how to graph linear equations. Y-intercept is -4. Slope is 2, excuse me, up to over 1. So, of course, this might be an imperfect graph, but hopefully it's that's what it looks like, and they want me to find the intercepts mathematically. So for the x-intercept, we set y equal to 0 and solve for x. x-intercept of 2. Looks pretty close. And then for the y-intercept, you set x equal to 0 and solve for y. Oh, I definitely know y-intercept is -4. So there you go. Now, if you wanted to write these as a point, get to y-intercept is 2, 0. I mean, x-intercept is 2, 0, y-intercept is 0, -4. Either way is fine. Number 6. Oh, same thing, just different equation. Y equals -x² plus 4. Now I know this is going to be a parabola, but I'm not quite sure about all of it. So the thing you can always do is just simply start finding some points. So when x is 0, y is 4. When x is 1, y is 3. When x is -1, y is 3. When x is 2, 0, -2, 0. Let's see what that looks like. So zero, 4, 1, 3, -1, 3, 2, 0. So I think we get an idea. Now mathematically, calculate the intercepts. So intercepts at y equal to 0. I want to solve for x. So I'll add x² to both sides. If I'm at x², I want to get x, I need to divide or take square root of both sides. Don't forget though, square root of 4, the answer is plus or minus 2. So there are 2 intercepts, which looks about right. So for the y-intercept, set x is equal to 0. And there you go. All right, intercepts. Let me take a break here now. We're getting ready to start circles. Let me stop this video and then we will start again with circles.